Okay. So, welcome back, everybody. This is not any of my main series. Not sure if I'm going to be putting this out there, but wanted to be able to have some footage of my uh, second attempt on a smaller scale, actually, to create a Booth algorithm multiplier. And as you can see, I've got some nice fancy textures going on, some nice fancy shaders going on, but that's besides the point. Here is my interface. we are go we have a multiplicand A with these 4 bits, a multiplicand B with these 4 bits, and a result up at the top, our product. And this bit is in gold because it is an extra bit and technically not a part of the answer. And we've got a multiply input here and a clear input here. But first things first, I have what is it called? A shift register to create. Okay, redstone. For the shift register, I am going to, we do not need those blocks anymore. This time I'm going to try to color code my redstone so that it makes more sense. For the shift register, let's do magenta for the shift register. I've got PTGI going on. This is E12, and that is by Sonic Ether. So this is not the most updated one, and the resource pack is, just as an aside, let me just show this to you. This is Modern Arch R211. So, and this is one of those resource packs that is specifically designed to work with the path tracing. So that's why you've got all these nice little angled facets that you can see here. Okay, but anyways, shift register. Of course, if we want to light up both of our redstone lamps, placed you in the wrong place. If we want to light up both of the redstone lamps, we do have to make it send power to the top one. Lightning rod. Well, yeah. I'm in Minecraft 1.19, so yeah, this is all these different textures. They are new blocks. Pretty much everything after 1.8 is brand new to me, or maybe 1.9. I'm not sure, because I have barely been playing at all. So that's fun. Don't think I'll need any hoppers. The daylight detector, that looks like something out of Feed the Beast. Okay. Oh, come on. Place, please. But yeah, the shift register is just going to be a long stream of repeaters that all lock at the same time. Which is an important thing. I should be able to do it this close. Hey, that one's missing its things. Hey, words. Additionally, with this resource pack, it is only about 40% complete. So, if you can see down there, the observers do not have their own texture. It is just default. But that's fine. Okay, that is the last one in the series. Okay, let's see how I was doing it over here. Yeah, I've got... I'm redoing it on a smaller scale because this one I got to... I remember I was over here and then I just got out of everything, and so I don't know what's going on. I don't know where I left off, so I need to start over again so I know where everything is, and that's also part of the reason why I am recording this. Okay. Just got single ones between that, but we do have space in between. Now here's the problem. We have all of these, and this I am sure is longer than... Oh goodness, that is really textured from a distance. Come closer, you don't see it as much. Okay, so shift register. We are going... It has to go this way because... As you go down the multiplication, the number shifts that away. So we got to make the shift register go that way as well. Although that's... Well, if you know the Booth algorithm, that part is obvious. Well, whichever way you're trying to shift, that part should be obvious. Okay. Need to do that. Okay. So we have this part of it done. Now the next question that needs to be answered to make sure that this is infinitely tileable, because that is an important factor to me. Just like the full adders that I am using, those are infinitely tileable. You just have to make sure that whatever inputs you're supplying, it is a 5-block difference. So, the idea that I have is that we start from this end. And so this one because it is at the end where the number is shifting out of the line, obviously we don't care about it, but we need to shift that signal to this repeater. So over here, let me I need... So this is the default state. Okay, let me put a button here. And take a look at the stone button. Oh goodness. Little power button. But anyways, we need to invert this incoming signal. And then when we click this button, we will be able to, this will clear out and get whatever signal that one has. And then after this one goes, okay, the nighttime is very dark. Let me turn that back. Okay, let me put a bit more over here. And okay, do we have enough room? There is a 1 tick pulse between what am I trying to say? There is a the redstone torches have a 1 tick pulse. So we need to invert this. And then after inverting it, we need to invert it again. So let us try this. Okay, that is not going to tile very well. What we can do is go down the side. But which side? Do we have enough room over here? So 1, 2. Of course, we do need to get that out of there. So that will give us that. Okay, so what I want to do to just keep things okay. When this is off, that is off. That is a good sign. Okay, so let's get rid of that and put our button here. And of course we can get rid of that. So now we demonstrate our infinite tile ability. Okay, so we have this part. Now let me just supply a bit of redstone here. Actually, we do not want that there. Oh, come on. Let's go with this. And we might need to make that into a monostable circuit, but for testing purposes, let me put that there. And then, actually, this should be able to test whether we need the monostable circuit or not. If we do that, okay, yeah, we lit up 3 of these. We only want 1 of them lit up. Actually, no, I still want that there. Oh, no, I will leave it taken out. But now if we press this again, those 3 pulses advance another 3 pulses, which is not what we want. Okay, let us create a little monostable circuit. Okay. Okay. Still want the magenta. We still want the button. We do not need that yet, but the observer is something that we do want. Let's just use that as a building block for now. And put the observer pointing that way. And this, and a button. Now, if we have a continuous input on over on this side, okay, was that too fast? It's a possibility that that may be too fast. So, there's another type of monostable circuit. I'm leaving the nighttime on for the moment because it will help us. Let's see more easily. Let's see. Okay, did that work? It does not look like that worked. What if we put that to a 2-tick pulse? It did. And it went one single time. Let's break that. See that go down, and it proceeded one step. Proceeds one step. That is the operation that we want. Now the second test, let's get that going again. Let's click that. Now we have 2. And now we have 3 total lights going. One, 0, 0, 1, 1. And now that we still have that space of 3. And that is operation that we desire. Good. We have some stuff that is working. That is great. Okay, next order of business. Now that we have our shift register, our next order of business is that we need to... Oh wait, there is actually one test that I need to do. Let me put a redstone block there. If I provide this, then that one gets loaded. And then we remove that pulse, and that one stays the same. Oh hey, that's an easy clear button. Okay, so this one is by default on. Oh, we won't worry about the clear button. Actually, yes, we will worry about the clear button, because that will be a simple one to finish. Okay, clear button. We do not want that to be magenta. Actually, clear. Let's do white for clear. We don't need that, but we do want that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, okay. Where are you? You are here. You are here. Let's put that there. And then that's going to go and activate there. Do we want that to activate there? No, we do not, because then it will just power it, and we want to unpower it. So we put that there. Okay, that's got everything unpowered. So what can we do about that? We can actually just do this about that. So that is our clear function. Let's just quickly load up a random number. Actually, we want to do that. Let's go back and remove this. So now we have a light down at the very end. We want to make sure that everything can be cleared. Hopefully, a wooden button should be able to do the job. Nope. Which means that we need a pulse delay. Okay, we just killed some redstone. Okay. Yeah, we do not want to kill that redstone, but we did just kill that redstone. Which means that this does need to change slightly. How shall we do such a thing? We can do that. Actually, let's bring this down a block. White wool. Let's put that there. Slap a torch on it. Okay, so we do need that. That is not good for the redstone torch, though. Actually, let's go, let's try this. So if we have our, is that exactly the same as what it was? That is exactly the same as what it was. But what we can do is bring this down one more block and put that like that. There we go. We can get rid of that. Now all we need to do is lengthen this pulse. We need we need the redstone to go into that. So what we can do is do that. And go like this. Now we have 2 repeaters. Should be able to make that go for as long as we need it to. Let's load that up. Now if we clear that, that goes all the way down there. What about if we have this at a total of 5 redstone ticks? Ah, come on. There we go. Now let's use redstone blocks, because that will be simpler. If we do that, okay, that went down that far. What if we, did that actually go any further? It did. 1. Now we do that. We've got that at the end. Now if we click this button, it goes all the way to the end. Okay. Oh wait, that, okay. First of all, let's see if we can just add another repeater there. It's on. We click the button. That is still yes. Okay. And we do not need any of this extra wool. Wonderful. Okay. Let's see here. When we click this button, that is going to be yet another wool color. Let's use the yellow. Oh, that is not wool. Okay, so when you start multiplying with the Booth algorithm, this operand gets loaded into these four slots of the shift register. So we will want to bring this over. Okay, one moment. Okay. We will want to bring this over, and because we are going to need to split this off in several places, so let's just bring it on out. Actually, I might want to have this okay, let's get our yellow and cyan. But I want to get rid of that because I think I want to have this information coming out over on this side. So, okay, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Or wait, no, we want to make sure that we have the room. So let's just do 1. Then we just need to get this information over to so for this one, this is coming from that. This needs to go and join this line over here. Oh, that cannot travel like that. So, nope, that will not work. So we do that. How does that look? All we really need to know is if there's redstone here, then it'll get loaded in. Oh wait, but we can't do quite just that. Oh goodness. Goodness gracious. Okay, let's change this a bit. Let's try bringing this out a bit more. And over here, we will actually have or let's have a block there. No, we need that there. And then sticky piston that. This shouldn't be grabbing anything, which is our intended use case. Over here, this is where the piston is. We've got as much room as we need, so let me pull off a monostable circuit over here. Okay, maybe okay, we need to lead our redstone over here. Okay, so we will need our observers sitting here. With the 1, 2, 3, and that over there. So if we do this one first, okay, so, well, no, we won't have to worry about that because we already know we can load it in with just a 2-tick pulse over there. We do not have to worry about that. Let me bring this down. We can't go there. Well, let me add that to the rest of them. Okay, so I got that set up, but I should probably mention that. Oh wait, of course. Let's set the time back to day so everyone can see. I have some toggle flip-flops over here, so that already installed. That's what all this slime is for. So I've got all the pieces filled out, so let's try doing 1101. And then this is the next thing to test. Oh. Oh, okay. So, what's going on there is that everything is still passing. It is still passing their information through. So, this line is still passing information, passing a 1 to this display. I'd love to make that a one-way, but I do not have the room to do that. Okay, so I just added this in and clicked the button, so now the button has to be powered for these signals to reach up here. So now what we need to do is connect a pulse from the multiply input up to here. So along this same line, what do we need to do? Okay, so let's go with an observer monostable circuit. Oh, right, we do have to do that. And make sure that that is a 2-tick pulse. Let's do that. And let's see here. We don't have any woolen slabs now, do we? Do we have a slab that is a bit yellow in color? Well, sandstone slabs will work for that. More of a brown. Let's just use you for convenience sake. Are we going to get interference from there? Not yet, at least. If we go like that. Let's do that and bring our yellow over here. So now we should be able to oh wait, what did I do there? Okay. Well, that was an absolute failure. Well, I suppose that doesn't need to be a half slab. But we can go like this. So now it should be able to go straight up, around, and then that'll turn the torch off. So let's press the clear button. That's done. We press the multiply button. Ooh, that's some interesting things going on there. But we do see that we got information loaded, so that's a good thing. But the biggest thing, however, is that... Okay, this needs to be delayed. How do we delay it? What? What if we go like... Oh, you can shut up. If we go like this, okay, how do we... Okay. Then the other thing is that we need to keep the 2-tick pulse. So, let's do this. And we've got that. Another 2-tick pulse. Because we need to... Oh yeah, okay. This needs to be delayed. This needs to be lengthened. Two things going on here. Okay. But what we can do with that is just delay that line because this is monostable to reduce it to a 2-tick pulse. Let's see here. That should work as far as that goes. Oh, wait, what am I doing? Oh my lord. Okay. Let's clear. Clear, and then let's try that. Okay. Have you ever created a pulse lengthener that has gone on a stairway? Oh, well, that failed. Oh, goodness gracious. Let's try this button again. Okay. Okay, that's... Obviously, that is powering itself. That's not going to work. What we can do to fix this, however, is move that, put that there. Now this is a one-way circuit. 1101. If we clear, okay, that is just barely not long enough. Okay, so okay, we are going to have to, okay, so that's a corner, that's not going to stick. We need to bring that out, then 1 and 2. then we can bring that over like that. Okay, so let us add this on. 2, 3, 4, and then let's give that, let's try that with 2 ticks there. Turn that off. Well, we clear it, and now we multiply. And it loads up correctly. Beautiful. Okay, let me... Okay, the next step is we have to add our adders in. Okay. Okay, so I see over here in my first one that I have actually two full adders on each of these, which I do not remember why I made that decision. Could have something to do with the fact that I only have one row of lights and not two. So, let me explain the Booth algorithm. And let me go over to this side. This is the most significant digit. So basically, if you were to write down 1,200,005, the 1 for 1 million, that is your most significant digit in a decimal system. Well, this is binary. So it's either on or off. But this is the most significant digit, and this is the least significant digit in our shift register. And this, of course, is our extra bit. So, what happens is, obviously, as we have already implemented, this, the one of our multiplicands, which is half of the total shift register, is going to be loaded into the lower for significant digits. Well, in our case, we have 8 total bits, and then down here is 4 and 4. So we have the four significant digits, and we load this number directly into these 4. And then what happens next is that we take a look at these 2 bits in the shift register. And depending on what those 2 bits are, we perform an operation. If these bits are 0 and 0 or 1 and 1, we do not do anything. If these bits are, as it is right now, 1 and 0, we subtract this value from whatever is over here, from what is in these top 4. So, and we don't have a carryover, so if we subtract, and if there's say a 1 over here, if we just have 1 in here, then what it's going to happen is this will end up being 1, 1, 1, 0. If, however, these final 2 bits in the shift register are 0, 1, we will add what is down here. And for each round, that is what we do. Okay, so I went over and I copied my example of the full adder from over there, so I don't have to run all the way over there to look at it. So what do we need to do? So for these 4, I want to get rid of the rest of this wood. I've had enough wood for today. Okay. Okay, what do we do? What do we do? We need to... Okay. So, taking a look at my full adder. If someone else came up with this design, well, I will have you know I came up with this design a long time ago. Back when I was still in college, which was it was probably 4 or 5 years ago at the minimum. But it is a nice compact design. It is infinitely tileable. So like this over here is going to be your carry in, and this is your carry out. This is your input A and your input B, or A and B. It doesn't matter. And then here is your out. So, I did a test over here. This will work. And it should also work if I were to have a... Let's pretend I have a redstone torch up here. That will work as well. Obviously, if we get rid of that piece of redstone, it does not work anymore. So, I am... Let's see here. Let's see here. Obviously, the two inputs have a spacing of 2 in between them. They're 4 blocks apart. Do I want to... I'm deciding which side I want to input. So, probably I want to build it using this side coming from the button. And I did realize why I had the second one. It is to do with there is a bit of it that I can't explain because okay, there is a line somewhere here that is supposed to turn it... I do not know. I don't know. I don't know. I need to stop looking at that thing because I have no idea what I was doing there. Okay. I want to use this as the input from the button. Because this input comes... I'll have to draw from... Okay. I'll have to draw from this. Okay. But there is another question to be had, because I'm going to be both adding and subtracting this number. And therefore, I need to be able to turn this 4-bit number negative. And to turn a number negative, you need to do... You need to invert all of these numbers. So let's just show this as with these 4 buttons. You invert everything, and then you add 1. That is how you make a number negative. At least in binary, that is. Excuse me. Let's try it with this number. This number currently is 1 plus 2, 4, 5, and 8. This is 13. If we want to represent negative 13, we invert, 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 and invert, and then we add 1. Of course, technically, this should be a... This number over here should... What am I trying to say? Well, this would be an overflow. That's what I'm trying to say. Okay. Okay, so when we subtract, let me take a look at this, at my notebooks from college. Well, just the one. Okay, so this example I have here, you can't see it, but I can. We have a multiplicand of 0,1,0,0,0,0,1, and obviously on the first time to go through it, we subtract. Well, the operation ends up being subtraction. And so, okay. So 0,1,0,0,0,0,1. We have 1, 2. Okay, we have 7 digits there, and in the shift register, I also have 7 digits there. But when you shift, that carry, which would be sitting over here, also gets shifted. And if you have a no operation, you just shift again and you still shift over a 1. Okay, so okay. Which means that I need to take this and mirror it. So let me go and do that just so that I don't have to think about every single time I look at it there.